Hello, my lovely learners. How are you? This is Class 9 Mathematics. This is the third part of the chapter Triangle. In this video, we will discuss the isosceles triangle property. Before we move to the isosceles triangle property, let us discuss why does SSA not work. Because many of my students ask me that why their side-side angle congruency does not work. The reason is here. Suppose we draw a triangle. The triangle is already made here in which angle side and side is given. If we produce the line segment AC, you can see in the figure 3b, what will happen? Swing segment BC across until it touches the extension of segment AC. You can see in the figure that we can draw a same segment BC dash. Then also the angle does not affect, the angle remains same, this side remains same and this side remain same. So we have just created two triangles. Now compare the first triangle and the 3D. The triangle 3A, the figure given in 3A and the triangle given in the figure 3D that have SSA congruency. Yes, they have SSS because we did not change the angle in all of figure. The angle is remain same, that side is remain same, this side also remains same. But can we say that these two triangles are congruent? No, we cannot say that these two triangles are congruent. Now, let us move to the isosceles triangle property. So what is isosceles triangle? A triangle in which two sides are equal. We can see that PQ and PR sides are equal. So if in a triangle, if any of the two sides are equal, we name it as isosceles triangle. There are two very important theorems based on isosceles triangle property. The first one is angle opposite to the equal sides of an isosceles triangle are equal. So what is given here? That the triangle is isosceles. That means two sides are equal. Let us take AB is equals to AC. So what are the opposite angles? Opposite to AB is angle C. Opposite to AC side is angle B. That means what we have to prove is angle B is equals to angle C. Next, for this triangle, we need a construction. We construct a bisector of angle A. What do you mean by the bisector? Bisector is a line segment which divides the angle into two equal measures. So, when you start the proving, you must write down the triangle you are taking in triangle ABD and triangle ACD. AB is equals to AC because it is already given in the question that it is an isosceles triangle. The second thing is you have constructed, that means angle BAD is equals to angle CAD, and the third one is AD is equals to AD. So what are the parts you have taken? You have taken this side, you have taken this angle, and you have taken this side. That means by side angle side congruency, you can write down that these two triangles are congruent, and when the triangles are congruent, their any parts, their remaining parts, that means B is equals to angle C by CPCT. So what is the full form of CPCT? Write down in the comment box. The next very important theorem is Just reverse of the previous one. The sides opposite to the equal angles of a triangle are equal. What is given is angle B is equals to angle C. So what side is opposite to angle B? Yes, it is AC. And which side is opposite to angle C? That is your AB. We have to prove that AB is equals to AC. For this proof, again we construct a bisector of angle A. The meaning of bisector is the line which divides the angle into two equal measures. That means angle BAD is equals to angle CAD. You consider a triangle BAD and triangle. When you write down a triangle, you must write down the corresponding vertices B corresponding to CAD. So what is given? B is equals to angle C, that is given. Then you can write down angle BAD is equals to angle CAD by construction. The third one is AD line is common in both. So you have taken this angle, and this is your side. So by angle side congruency, we can write down that these two triangles are congruent and hence AB is equals to AC by CP/CT. I hope both the theorem is clear to you. Now based on this theorem, we will do few more questions. Remember, when the sides are equal, the opposite angles are equal, and in a triangle, if the two angles are equal, their opposite sides will be equal. So next question is, ABC is an isosceles triangle in which altitude BE and CF are drawn equal sides AC and AB. What is given in this question is AB is equals to AC, and what is the term altitude here? Altitude, that means CF is perpendicular to AB and BE is perpendicular to AC. What we have to prove is, we have to prove that these altitudes are equal. That means BE is equals to CF. Can you observe two triangles in which we get these two sides BE and CF? We can write down that consider a triangle. In triangle ABE, and take the another triangle AFC. Take the triangle ACF, write down the corresponding vertices. Then can you write down angle BEA is equals to angle CFA, because each 90 degree, these are altitudes. The second important thing is AB is equals to AC. These two things are already given. Find out the third thing. A is equals to A, which is common vertex. So common angle in both. So let us mark all the respective angles or side. You have chosen this side. You have taken this angle and you have taken this angle. So by AAS criteria, this triangle These two triangles are congruent and hence BE is equals to CF by CP/CT. So BE is equals to CF. I hope this question is clear to you. First, make the triangle congruent by finding the appropriate criteria, and then the remaining sides or angle you can write down they are congruent by CP/CT, that means corresponding part of congruent triangles. Next question is, ABC is an isosceles triangle in which AB is equals to AC, side BA is produced to D such that AD is equals to AB. That means you have given all the three sides are equal. AB is equals to AC and AB is also equals to AD. To prove, show that the triangle BCD is a right triangle. Make a correction here. It should be triangle BCD. So that means you have to show that angle BCD is 90 degree. Let us prove this. For our convenience, mark it by 1 and 2. Mark angle ACB is 1 and angle ABC is equals to 2. Since AB is equals to AC, can we write down angle 1 equals to angle 2? By the theorem, you must write down the statement of the theorem. When the sides are equal, their opposite angles are equal. Angle opposite to equal sides are equal. Now, mark this angle ACD by 3 and angle ADC by angle 4. Now again, since AB is equals to AC and AD is equals to AB, can you write down AC is equals to AD from the given? So, the same theory, 3 is equals to 4. Angle opposite to equal sides are equal. Now, in triangle BCD, the sum of all the three angles, that means angle 2 plus angle 4 plus angle 1 plus angle 3 gives you 180 degree. Now, the remaining part I am doing here. So, since 1 is exactly equals to 2 and 4 is exactly equals to 3, can you write down 2 times angle 1 plus angle 3 will be 180 and angle 1 plus angle 3 is 90 degree. Dividing both the side by 2. What is 1 plus 3? That is your BCD is 90 degree. Hence, this is your proof. Now, applying SSS, can the triangle UVW is congruent to triangle MLN? Check out by comparing the corresponding sides. If you get the same value of x, hence they will be congruent. Write down the correct answer in the comment box.